Last time we traced Python all the way down to NAND gates. In this episode, we'll go through the software stack for machine learning. Just 3 lines, but what actually happens here? Import torch takes seconds. Why? Kuba moves data to the GPU. What does that even mean? Today we trace the software stack, every layer between your code and silicon. First, we need to talk about the operating system. The OS is software that manages everything else. It does 2 critical things for us. 1. It manages memory. Each program thinks it has memory all to itself. The OS maintains that illusion. It tracks who owns what and prevents programs from stepping on each other. 2. It schedules work. Your computer runs hundreds of programs at once, one CPU. The OS gives each program a slice of time, switching between them thousands of times per second. This is why your music keeps playing while you type. The OS is the foundation. Everything we run sits on top of it. Now, import torch. When you import a library, Python loads code from files on disk. But PyTorch isn't just Python, it's massive. Most of that is compiled C++ and CUDA code pre-built for speed. When you import torch, Python does the following. First, it finds the torch package on disk. Second, it loads the Python modules. Third, it loads compiled extensions, .so files on Linux, .dll on Windows. Fourth, it initializes CUDA if available. Finally, it allocates internal data structures. Those compiled extensions call into even deeper layers. Your Python code at the top, PyTorch below that. cuDNN, or NVIDIA's neural network library. CUDA runtime, which is the GPU programming interface. GPU driver, which talks to actual hardware. And finally, we arrive at actual GPU silicon. Each layer translates your intent into something the layer below understands. That's why import takes seconds. It's loading and initializing this whole tower. Now for a twist that can trip a casual user. Your computer has 2 completely separate pools of memory. System RAM, where your Python variables live, connected to the CPU. GPU VRAM, video RAM, on the graphics card. These are not the same memory. Data in one is invisible to the other. When you create a tensor in Python, it lives in system RAM. The CPU can touch it. When you call .CUDA, PyTorch copies the data across the PCIe bus to GPU memory. Now the GPU can operate on it. But the CPU can't see it anymore. It's in a different world. This copy takes time. That's why we try to minimize CPU-GPU transfers. This leads to the most common error in deep learning. Runtime error, CUDA out of memory. Tried to allocate 2.00 gigabytes. Your system might have 64 gigabytes of RAM, plenty of space. But your GPU may be 8 gigabytes. And that GPU memory is precious. It holds your model weights, your input data, intermediate calculations, gradients during training, and optimizer state. A large model can easily need 10 to 20 times its weight size during training. When you try to allocate more than exists, it results in error. The fix: smaller batches, smaller models, more GPU memory. This is why people obsess over GPU specs. VRAM is the bottleneck. And why NVIDIA's A100S with 80 gigabytes cost as much as a car. Between your Python and the chip, there's an intricate tower of software. The OS manages memory and schedules work. Libraries like PyTorch provide high-level operations. CUDA and drivers talk to the GPU. Each layer adds convenience. Each layer adds overhead. Understanding this stack helps you write faster code and debug when things go wrong. Next time, we dive into how numbers are actually represented, the math that makes it all precise.